So we'll start with just what is a high bay space. The high bay term comes from warehouses originally, and that was anything with racks that had a 36 feet in height or higher. So obviously very, very tall. When we think of it in the design industry, we use it much more broadly. Anything above 12 feet is where we'll start to consider that a high bay space because of the challenges with delivering the air and keeping a consistent temperature in the space and all that. So like I said, common applications for these would be atriums, auditoriums, gymnasiums, airport terminals, casinos. Anything with a high ceiling that's greater than 12 feet can be considered a high bay space. So we're going to get into two different methods of design here, because obviously when you have that higher ceiling, there's different challenges you have to be aware of. One of those with the mixed air system, the Foley mixed air is the most common approach. And one of those challenges that I mentioned is destratification. The hot air and the cold air will tend to separate in those taller spaces and be much more dramatic. So to combat those, you can use some HVLS fans, some high volume, low speed fans, or destratification directional style fans as well. The other strategy you can use in these spaces is displacement systems. So this is a low speed, low supply. You're supplying low on the ground. It's finding a heat source and it's rising up to the ceiling with a high return. So it's a single pass system, much more ventilation effectiveness on that system as well, where you're delivering, like I said, you're delivering the air low and you're returning high. So it's kind of a single pass system. You're not mixing the space. You're actually encouraging a stratified space to induce that air to travel up to a high return. So typically with those, you're looking at an underfloor system or a sidewall system. Those are the most common ones, but there is some overhead systems as well that can utilize displacement strategies as well that we'll get into. Okay, so the methods of design and things you need to kind of take into account when you're looking at these spaces. So in that picture there, we see an airport terminal and we see some jet nozzles on the side there. So jet nozzles are one way that we can combat, one of these 5 performance mandates with being temperature, air movement, humidity, quality, and sound. So making sure we're getting that air within the space on those wide, high atrium style spaces is critical. And then we use these 3 ASHRAE codes typically to look at high bay spaces: ASHRAE 55, ASHRAE 62.1, and even ASHRAE 90.1 in certain cases as well. We'll touch on some high bay spaces. So one thing to keep in mind with high bay spaces is that occupied zone. So ASHRAE 62.1 defines the occupied zone as being 6 feet above the finished floor and 1 feet away from the interior walls and 1 meter or 3.3 feet away from the exterior walls. And so that is the occupied zone. That is what you're trying to maintain with a good temperature and humidity. And the challenges in a high bay space is that becomes a very small fraction of your space. So, as you reduce that fraction of space being occupied zone, you have a lot more challenges because there's a lot more space where you're not as worried about, but you have to get the air through it and into the occupied zone. So considering how effectively you can condition this zone, as I mentioned, stratification is a big one. And then with the zone air distribution effectiveness as well, we can factor into these considerations. So the goal of a mixed air system, and this is the most common approach that we see, is to just deliver the air, rapidly supplied along the ceiling, and just mix the air as much as possible. Force that fresh air into the space and mix that air to get your ventilation requirements in there. Typically, you're looking at about a target of 50 feet per minute into that occupied zone. And we typically don't see anyone exceed 70 feet per minute, or wouldn't recommend exceeding 70 feet per minute. And then to keep draft temperature between 3 degrees under +2 on the high side, just to eliminate any draft zones or anything like that. So that is a typical mixed air system. And as you get into these spaces with a higher ceiling, so that picture on the left is a typical space, maybe a 10-foot ceiling, and that's a good mixed air system. You don't see too much stratification between the floor and the ceiling with temperature differential. On the right side, once we get that ceiling above 10 feet, we start to risk that stratification. So now you can see that hot air sitting at the top. It's going to take a lot more energy and air, velocity to push through that hot air sitting on the top. So you're going to get into some wasted energy concerns, some thermal comfort concerns, and even some indoor air quality concerns, because you're having trouble getting that fresh air into the occupied space with that stratification that is occurring. So one way we can combat this is jet nozzles, as I mentioned. So think back to that picture with the airport terminal there. There were some jet nozzles on the side. So these use a high velocity air that travels out into the space at high velocities. And during that high velocity area, you can see that air is actually being entrapped into this airstream, and then it dissipates out. And as we get into a lower velocity, it starts to dissipate out into the zone. So these can be very high throws. We can throw these across the room pretty effectively. And there also do have some damper styles on the back as well that we can actually utilize to throttle these down up to 50% in some cases. So in a lot of cases with jet nozzles, there can be a concern with noise. But in a situation like that airport terminal, we're not as concerned with noise in those situations. So jet nozzles would be a great approach there. And we use air concepts for our jet nozzles. So here's some examples of air nozzles. They can be wall mounted in a single and a combination of multiple quantities in one. We can put these on spiral duct as well. Same thing with these jet nozzles. And as I mentioned, behind these ones, there are also some damper styles to help throttle these throws down a little bit. And then we also have some drum louvers that can also be installed on ductwork as well. Okay, so some things to consider when you're looking at these jet performances is all the jet performance is tested at isothermal conditions. So that means the same supply air temperature as the ambient or the room temperature. So those isothermal conditions. That is not obviously always the case in the real world. So you have to take that into account when you are looking at the performance charts on these. So that bottom part, or the rule of thumb, because this does have some buoyancy effect on these air jets. So every 1 degree Fahrenheit difference between that supply air and that room temp will impact it 1%. So in cooling, we'll actually get a plus 20% projection, and in heating, we'll have a minus 20% projection. That would be at a 20 degree differential, obviously. So 1 degree for every 1%. So just taking into account, typically we would recommend, or when I'm sizing something like this, I would look at the heating side first. Make sure you're good on the heating side, and you can back into your cooling side and usually be good in most cases. So just something to keep in mind when you're factoring these in and sizing these up. Okay, so I mentioned a few times about destratification. We saw that example of that destratified space with the hot air kind of sitting more towards the ceiling area. So one way to combat that is using HVLS fans, some high volume, low speed fans. I'm sure you guys are all aware of these. I'm sure you're familiar with the name big ass fans as well. We represent big ass fans in New England. These were actually designed for cows, actually, to keep cows happy. They found that milk production increases when cows were kept a little cooler. So these were actually invented for that application. But we see these mostly in warehouses, a lot in warehouses. We see these in gymnasiums, in atrium spaces. We can have an industrial style look with these, or even more of an architectural style look with different painting options for more of an atrium style space as well. They're great for heating and cooling, and really good for evaporative cooling as well. So have a cooling effect with that increase of air movement in the space. So you can actually dial back your set points a little bit on your air conditioning side when you're using big ass fans or HVLS fans to improve that cooling effect as well. And like I said, it will combat that destratification. So it'll eliminate those hot areas sitting at the roof, and they'll push those more towards the ground, creating more of an even space temperature throughout the area. So with Big Ass Fans, they have the Spec Lab software. So you can send in your selections, criteria, your floor plan, your space, and all that to your Buckley representative, and they can work with Big Ass Fans to generate a CFD analysis in their Spec Lab. And we could actually build out your exact space. We can put obstructions in the area. So this one we're actually looking at here is a gymnasium, or like a workout gym. So we can place Big Ass Fans in the model and then run it, and you will get a detailed 3D layout with some CFD analysis to see how they will impact your space. And we'll give you an average air velocity as well as an average cooling effect as well with that extra airspeed in the space. So as I mentioned with that cooling effect, this chart shows that cooling effect and the impact as air velocity increases. So as you can see, most effective in that 300 to 400 feet per minute range, and we're going to be getting about a 7-degree cooling effect. So what that means is, with that extra air movement in the space as people are running around the gym, whatnot, they're obviously sweating a little bit. That extra airspeed from this Big Ass Fan will actually help keep them cool. It will give them a cooling effect. So this example in this chart, this left side, we have AC only, so just the air conditioning units. We set those set points about 75, traditional style mixed air system. We're delivering the air at about 20 feet per minute into the occupied zone, and that works great. Once you add in Big Ass Fans or HVLS fans, you can actually utilize that cooling effect to your benefit and reduce that energy usage on your air conditioning unit. So you can dial back your set point about 5 degrees or wherever you're sitting on this chart. And that can also come from the Spec Lab analysis that I showed on the previous slide. We can show in detail this effect. So in this chart here, in this example, we have a new airspeed about 110 feet per minute, which is close to about 5-degree cooling effect. Which meant we could dial back that air conditioning set point 5 degrees and help get that, recover that cooling effect from the Big Ass Fan. So something to keep in mind there, and we'll work with you on that. We'll work with CVE Thermal Comfort tool as well to show some cooling effect as well, and some metrics. We'll put in the clothing levels, the metabolic rates, all that good stuff to generate this report for you as well. So we can stand by this with confidence that these fans will work as intended with that cooling effect. And then in heating mode as well. So the one thing out there, we don't actually reverse operation with Big Ass Fans. They work the exact same in summer and in heating. We're just destratifying the space, keeping that space a uniform temperature throughout. During heating time, you can actually get increased ventilation effectiveness up to 1.0 in heating months with Big Ass Fans as well. So that can benefit you in a mixed air system, especially. Okay, and then I also mentioned that we have directional style destratification fans. So we represent Arius, a great manufacturer out of Colorado. They do more of these directional styles. Most commonly is the Arius Air Pair model. Those are kind of what you're seeing on those bottom right there. So these are more directional styles. They do the same type of application, same type of benefit that Big Ass Fans will generate, but it's just more of a directional style. So we see these as in many high bay applications. We've seen these in grocery stores, more for aisleways, or for a warehouse with aisleways. We've seen these in field houses or more of a collegiate style gym. In many cases, we'll see these because, those collegiate gyms, maybe they don't want an HVLS fan over their volleyball court for collegiate sports, or if they have a big jumbotron that kind of drops into the center of the space, they might not have room for the Big Ass Fan. So this is a great solution for those areas. And then, like I said, field houses where they're playing baseball, playing football, stuff like that is another great application to utilize Arius for. So like I said, destratification solutions with more of a directional style approach. And they'll also come with EC motors on all these as well. And we can do some bipolar ionization in these for some air purification. So different options that you can utilize with these models. Okay, moving into the next strategy, which is displacement ventilation. So as I mentioned, mixed air system is the most common approach, but we also do see displacement used more and more. Displacement is a single pass system, as I mentioned. So you can see in the CFD analysis, the air is being delivered low to the ground at a low speed at about 40 to 50 feet per minute, coming out of the diffuser face. It pools on the ground with that low temperature, and then it finds a heat source, being the computer, a human, anybody, and it'll travel up that heat source and up into a high return area. So with these, we can usually supply a little bit higher. Typically during cooling, we're at 62, 63, 64, somewhere in that range. And then we can move up into a higher temperature during winter months if you wanted to. And then the return also is elevated as well. As I mentioned, the stratification is the goal in this space. We want to make sure that we have that stratification to help encourage that incoming fresh air to find heat sources and rise up and out of the space as well. So like I said, it is a single pass system, which really benefits in helping keeping the occupants healthy and really improving indoor air quality. Because of that single pass system, for instance, if somebody sneezes or coughs in that space, with displacement, it is typically going to be lifted out of the zone very quickly without impacting anyone else. As that single pass system, there's no mixing of the air. For instance, with a mixed air system, it could take up to an hour or two to really get any sneezing, affluence, and stuff like that out of the space. So it's very high improved indoor air quality. I'm seeing these a lot more in schools as well. Not necessarily a high bay application, but each school classroom, I'm seeing more and more displacement ventilation. There's more and more studies coming out there that it drastically improves in attendance rate for schools, which in turn drastically improves funding for schools. So it's kind of a benefit for all there. But same type of benefit we get for high bay applications as well. So like I said, single pass systems, it helps get those germs, viruses, any of that stuff away from the occupied zone pretty quickly and gets it up into the return area. So fewer sick and absent, as I mentioned, increased funding in many cases, and improves occupant performance as well. And it's just going to be natural convection. It's just going to find a heat source, find some bodies, and go up and out of the zone. And it's very low speed as well. So even if you have desk next to this, they're not going to feel cold. They're not even going to feel the draft, really. It's very low speed system. It's also very quiet system, which is a very good benefit for those school applications, as well as what you see here is more of a, an auditorium where they're, orchestras or piano playing, stuff like that, theaters, stuff where noise is more of a factor. Displacement ventilation is a great application for that. You can use these sidewall ventilation diffusers to really help deliver air into the space and then have that high return and really keep everybody comfortable with a really good indoor air quality. As I mentioned, the ventilation effectiveness, that E sub Z. So in small spaces with displacement, it's usually about 1.2. In large spaces, you can even get much greater than 1.2. So you can get a really high ventilation effectiveness with displacement ventilation in these high bay applications. And with that said, we have a wide variety of displacement diffusers from Price Industries. That is who we use. So we have the underfloor, we have sidewall, and we even have some overhead mounted options as well. These are engineered products, so we must make sure that we're designing these properly and precisely controlling the airflow coming into these devices. We don't want any just dumping out of this diffuser. We want to make sure we are engineering the the whole application here. And then for some complex spaces, we can utilize Price's Predict team for CFD analysis to really help out on those complex spaces. So for an example there, let me go back to this slide. So for a wide space auditorium, movie theater, stuff like that, we can get really creative with Price Predict team. For instance, typically these sidewall displacement diffusers have a max length, coverage length of about 35 feet. So if you have a 70-foot space, you can have sidewall diffusers on each side and you can cover the entire space, no problem that way. Once you get above that, we don't have to go away from displacement. We can utilize Price Predict's team, we can utilize some different products from Price team and come up with a solution. One solution we've done in the past is we had a space about 120 feet in length. So we had displacement sidewall diffusers on each side covering those 35 feet. And then we actually utilized overhead displacement direction down over the aisles. And they were engineered in a way that, you know, the air leaves those diffusers in a laminar pattern and it hits the floor at optimal velocity to really just hit the floor at that 20 feet per minute per se. And then it just pools right at the floor and helps cover that extra area that wasn't covered by the sidewall diffusers. It sounds counterintuitive sometimes when you think about overhead displacement, but you know, with these Price products, we're seeing more and more application where we can use those with great effectiveness. And we could put those over the aisles, like I said, and you're not going to worry about drafting this there because people are really walking up and down aisles. They're not sitting under an aisle, so there's no concern with the draftness as well there. And we can utilize that Price Predict CFD team to help show that in those cases. So all that to say is, you know, we have many different tools at Price and Buckley that we can utilize to make sure that we can help design your space with the most effectiveness. Okay, and then to help deliver this into the space, we can use AQC Blue Duct. So this is a direct bury ductwork HDPE material. It's resistant to mold and mildew. It's completely air and watertight, and it has a R10 equivalent value for air duct. So we see these a lot for delivering air into, especially if you're doing an underfloor system. You can utilize this underground duct, completely air and watertight. You won't have any issues with this system, and it'll deliver that air into the underfloor. We also see this, for example, on that picture on the right, we see this as well a lot in pool applications where we can deliver air into those sidewall floor diffusers there to wash the windows. And we can utilize Blue Duct to deliver that air. Okay, and that will transition into duct socks. So the second half of this presentation is going to be primarily focused on duct socks and only duct socks. So it's going to be, I'm not going to talk much about more of the application style of things. We're just going to get right into duct socks and go from there. So I'm going to skip over this video. Okay, so duct socks is out of Dubuque, Iowa. They are a American-made manufacturer, and they also have some global manufacturing in Mexico and China. So we see these all over the US, and they are a US-made product. There's a video. I am going to skip over that. We don't need to watch that. Okay, so they're the global leader in textile air dispersion market. So we see these, you know, typically they're kind of known as the pool guys in a lot of cases. Pool applications is a big utilization of duct socks. We see these a ton in pools. They're a great aesthetic look, and you can get really creative with painting these as well, that we'll get into as we move through this. The air dispersion on these, as we'll get into, is very strategic and customized. They will engineer the air dispersion out of these per your application. They'll orientate all their the nozzles and all that to make sure that we're delivering the air exactly where we want to deliver it. And then we also have a handful of different suspension options as well that we'll get into. Okay, so traditional duct stocks, open, finished ceilings, very exposed, aesthetically pleasing. They also do get into some critical environments with lab stocks or kitchen stocks or chem stocks as well. So different options there, as well as underfloor. So if you are doing an underfloor system, you can utilize that blue duct, as I mentioned, for the outdoor underground run. And then once you get indoor space, you can actually utilize duct stocks to pressurize that plenum, or even use them for railways, just kind of a blank section underground to deliver to another area as well. Okay, so next. Okay. So as we mentioned, applications, we'll get into it. There's lots of pictures in here for examples, but there is a wide range of applications. Pretty much anywhere where you would have exposed duct, you could put duct stocks in with no issues. And as you can see in a lot of these pictures, we can get very creative with the coloring options, with the painting options, or not painting, but color options. As well as some logos and stuff. We can pretty much get very creative with these, as well as big. We can get quite large with these. I believe the one on the left there is two 72-inch diameters stacked on top of each other to make it look like an oval. That is actually for Allegiant Stadium, where the Las Vegas Raiders play. And then the one on the right there, I believe, is 156-inch diameter. And that is actually inside the Las Vegas Sphere, in between the outer screens and the inner screens. They have these running around in there to help keep all those electronics cool. So you don't even see it really. It's not even an open duct, but we can utilize them for obviously a very unique situation like that. And I got a couple of pictures at the end of those I'll show you as well. And just some more pictures of that very large duct being put together. So different fabric types as well. We have a porous material and a non-porous material, and then we have those specialty options as well, like I mentioned, for like a chem socks, data socks, so data labs, data centers, stuff like that, where we have a little bit more critical applications. But most time we're going to be looking at those porous materials. It's not going to have any condensation because of that porous material, and that's probably most often what we're going to be looking at for that. And so with that porous material, there will be a little bit of a loss of airflow as you travel through this. So you can see those examples there of what that rate is on those porous materials. But we take into all that account during our design. We make sure that we're taking into account, and we're making sure that we can stand by what these throw values out of these nozzles are going to be. Like I mentioned, lots of different color and specialty options here. We can get quite creative. Almost any color you would want, we can make work. We would just need if you had, for instance, a very custom color, you could just send us that color code. They can create a little sample fabric, send it back to you. You can make sure it looks good, and we can proceed as that. We can also do some logos. So if you're, like a high school gym, we can do some logos on there. Toyota dealership. So if you have like a dealership or something like that, we can put on some logos. This one down here kind of looks like a bronze or like a copper pipe. We can get very creative with these options. Very aesthetically, architecturally pleasing solution. And then the air dispersion options, we can do an air porous fabric completely, where it's just kind of like almost like a displacement type, a very similar style to that. We can do linear vents, orifices, or even nozzles that can have a kind of a directional style, where you can change the direction or even close them completely. But most of the time we're looking at those linear vents or those orifices, and those are engineered and laser cut per each project to make sure that we're delivering the direction we want to and the amount we would want to. So some more examples here. Grocery stores is a great application for these. We can make sure that we're delivering straight down. We're not throwing it onto the produce or anything like that. Keeping all the food safe and temperature happy. That arcade one in the middle, we can get really creative with that funky looking fun duct style there that kind of matches that arcade style, as well as retail spaces. Anywhere where they're an open ceiling with exposed duct would be a great solution for duct socks. Ice arenas are another big one. Because they engineer their nozzles and their laser cut nozzles there, we can precisely direction and place these airflows coming out of these to make sure we're not hitting the ice and melting that ice or anything like that. So a lot of ice arenas have been done with duct socks. Some clean rooms as well. So this example here, these are the that kind of the completely porous material that's almost just kind of very critical environment, clean room environment. You can also notice that these are attached to metal ducts. So we can transition from metal duct to lab sock or to a duct socks with no issue there as well. And then the traditional suspension styles. So this is kind of the we kind of have three options, kind of the low tier, the mid tier, and the high tier. So let's just be kind of the lower tier, where it doesn't matter if they don't, if one scenario where I see most often where this is used is in a 24/7 operation. Because obviously, as you can see, when the system is off, it gets completely deflated. It's only just hanging by that single bar in the top, just a 1-row suspension or even a 3-row suspension, but it will look deflated when the system is off. So if you have a 24/7 operation system, this is a great solution because it doesn't matter because the system's never going to turn off. Because when it does turn off and then turn back on, there can be kind of a popping noise. So if you have a variable volume system where it's going to be changing airflow, you wouldn't primarily want this one. Think more of like a 24/7 operation or a constant operation where it's operating from 8 a.m. to 8 p.m. and then at night no one's there, so it doesn't matter if it's deflated. But just something to keep in mind there. Grow facilities as well as a great one. So these would be a great option for that one-row suspension because these are just going to be operating 24/7. If they do turn off and on, it's also a grow facility. It doesn't matter if there's going to be popping or not. The noise isn't going to impact the plant. So. Server rooms, data centers, another great application for this. So you can see the nozzles on this one. These are the directional style nozzles that you can include with these as well, and you can even shut them entirely off if you orientate it one way. You can close off an entire nozzle as well. I'm not going to get into this one as much. We don't see that one as much, but more examples of these suspension systems and colors. This is kind of our mid-tier one. This is internal hoops. Oh, sorry, I went the wrong way. This is our internal hoops system. So this is the one that I would say is most often used. Even when you start to get into some variable volume applications, you can still utilize this. When the system turns completely off, there might be about a 5% sag or deflation, but it's very minimal. With those internal hoops, it can really it can handle that variable volume application with little to no noise. There's not really going to be much popping on this one, if at any. So we see this the most often, and I would recommend this one the most often as well. Pool, gyms, warehouses, manufacturing facilities, anything like that would be a great application for these. So with pools, we can really make these pop. That one in the lower right there, you can actually see that it is an open ceiling. It actually retracts. Those two pictures on the right there. So these socks are actually exposed to direct sunlight a lot of the hours during this. I believe this is in the Fort Worth area. So a lot of hours of the year they're exposed to direct sunlight, and they have shown very little to no wear on those colors. So they do a really good job of dyeing these fabrics to make sure that that color is going to pop and last for a very long time. So great for pool applications. It can really help, really pop in that space and make the color really shine through. Manufacturing and warehouses, we can run these in lots of different configurations, down aisleways, anything like that, over certain equipment as well if you need to keep those cool. So really good for manufacturing and warehouses. And then this is kind of the high tier for hanging, would be our Skelecore pull tight system. So these will show a 1% at most when the system is off. So if you have something that is really going to be a high demand for variable volume, if you're going from 100% down to 50% of operation, 10,000 CFM to 5,000 CFM, this is when we would want to start talking about something like this. But in many cases, it can be a little overkill. So we just have to kind of fine tune on what the application is and what the airflow is going to be doing through the system on what we might want to do. But this is all internally supported and pulled tight at the very end, so it will make sure that there is no deflation at all when variable volume or when it is turned off completely. More pictures. Field houses is another great one. Ice arenas, practice facilities, just another great application for duct stocks there. And with these, you can also get creative with, some colleges or facilities might want their logos on there. So we can even work with that, make sure their logos are properly on those as well. Auditoriums, offices, these can be a very low sound product. So another great application for anything where there might be sound concerns for auditoriums or office spaces, libraries, anything like that, we can really work with you to make sure that we're performing with low sound. And then this is the final structure. This is kind of like the, the S tier of it. This is the Skelecore full tension system. So this is where you would get that zero deflation. So this is very rare, almost wouldn't really see this, to be honest, but this is what you saw in those pictures for the Allegiant Stadium option as well, for where the Las Vegas Raiders play. So there is some cases where you can use these, but you can get up to 110 inches in diameter. So if you get very big, this might be where you want to start looking at this, just because it gets so large. So here's some more examples of how big these are. And they're typically about a pound and a half maybe per foot. So a really lightweight product as well that really helps out installing these. And all of these can be taken down as well, and you can run these into an industrial washer with a mild detergent, cold water, and you can just wash these like any other fabric, really. So easy to maintain, easy to clean as well. In that top middle picture, we can work around obstructions, so that screen actually can rise up into that ceiling space. So they went around that screen to make sure that it can accommodate when that jumbotron is raised or lowered. So yeah, as I mentioned, fabric versus metal. Anywhere where you use fabric or metal duct, you can use fabric duct. What's also nice about fabric duct is they use these kind of these pressure regulators inside the ductwork itself. I'll show you an example of that in a little bit, but that will actually help maintain the proper static throughout the system and airflow, which can make sure that we can do a uniform diameter throughout the whole run. We don't have to taper down like you would with metal duct because of that. So we can also improve that. And we can also disperse throughout the entire run as opposed to having to put diffusers every so often. We can also get very creative with retrofits and some tight spaces. So this is actually a job down in Chicago, Illinois, where it was a retrofit. They couldn't put anything on the roof and they couldn't hang anything from the roof because it's an old building that didn't have very good structure. So they put these, because this is such a lightweight product, they could use duct stocks in lieu of metal, and they could run these right between those joists. There's maybe a quarter inch, half an inch, if that, between the joist and that duct. So we can run these in very tight spaces as well. It can really just simplify the layouts as well. So we have a layout here. That bottom section would be a traditional style where you have that metal duct tapering down, and then you have those diffusers shooting off. And then that top would be example with duct stocks. And then when you look at the airflow pattern, you can see that you really get a better performance and a better overall dispersion throughout the space with this duct stocks product versus kind of a metal duct situation. Different fittings and options, lots of different transitions and elbows and radiuses, and they can get very low with their radius options as well. So for example, this option, they have a 3-degree elbow, I believe is what they have, to make this look like a round, a completely round solution. What's also unique about this one is you can kind of see it. These are the vents coming towards us, if you can see my mouse. The vents coming towards the back area, towards the nosebleed sections. And then you can kind of see on the other side, that's where the other nozzles are. And they're actually being thrown down right at the floor. And so we actually have 2 different throws going on. We actually have a much further throw going down to the floor than we do up here. So we're actually keeping both the customers and the attendants, people in the crowd happy, as well as trying to keep the coaches and the players happy down on the floor. So we don't have to do a uniform, 3 o'clock, 6, 9 o'clock situation. We can do one at 7 o'clock, one at 4 o'clock, whatever that turns out to be. We can get quite creative with adjusting those and making sure that we're throwing properly in 2 different areas, 2 different directions in many cases. Half round, quarter round options as well. So not just totally round. We can get a little bit creative with these. A very tight space. So this is like a shooting range with a really low ceiling, and they can put their diffusers right in there. They can also do some C-series fabric diffusers. So for warehouses, we can do a fabric diffuser style as opposed to a metal 4-way diffuser. Some more options there. The D series, F series, B series. So we can get very creative, lots of different options that they've developed over the years for different applications. That D series being mostly for those sensitive, critical applications that we've seen in the past. So this is an example of those D series. You can see them up here on that middle picture there, example there. Okay, as we get into sizing these, so typically we're looking at about 1,600 feet per minute for straight runs, a little bit less for those fittings. And then for low noise, we'd even go less than that. Standard optimal, we're looking at about 1/2 inch of static throughout this whole run is what we're with the typical sizing constraint there. So here you can see these AFDs, these airflow devices. They're almost like kind of like a basketball net kind of thing, where they're patented and designed from duct stocks themselves to help maintain a constant pressure in the system, maintain pressure as we get further and further down the line, and we can have that constant diameter throughout. I've seen runs up to 300, 400, or 500 feet, all of a constant diameter, with and utilizing these AFDs to help maintain that with no issues. More examples, some storage facilities. So like I said, very tight spaces where you might not think you can fit duct, you can squeeze some duct stocks in there as well. So here's the typical layout. This is something that we can get. If you have something like this, you can send to us. We can work with duct stocks. This is something where on this left side, this main run is a metal flat oval duct. It tapers down to a smaller duct, and then we get into the duct stocks here. We can also go back to duct stocks, and we can provide the entire thing duct stocks. So this is even duct stocks here. If you want to keep that tapered down look here, or if we just find out that we need to have that tapered down and ensure airflow, we can do that. And we can supply that entire thing instead of having this main run being metal as well. So just something to keep in mind there. We can do our T's. These T's are rotated up. We go up and over. And then we'll also show you the throws as they are leaving the vents. So we size the vents at 4 o'clock and 8 o'clock, throw values at 50 feet per minute, 100 feet per minute, and 150 feet per minute. As well as showing you, as I mentioned, with these being, most of these being porous fabrics, we'll even show you how much CFM is being lost or distributed out from this porous fabric, and we take all that into account to make sure we're getting the proper airflows that we need. We'll also provide all the drawing details that you might need to put on your drawings as well as full specs that you might need. We can provide specs as well. One thing to note is that these are actually under UL 2518, which is actually a diffuser product. They're not under the duct classification. They are actually listed as a diffuser. One thing to keep in mind there. And then some design and performance warranties. So there'll be a 1-year design and performance warranty. So no matter what, to make sure that these things are properly designed and performing correctly throughout the year, so we can see a full cooling season and a winter season or heating season to ensure that we're properly designed. And then after that, everything will get a minimum of 10-year warranty as well. And then code compliance, as I mentioned, they are classified under an air dispersion diffuser metric and not necessarily the duct metric or duct code. Also an EPD documentation, so if you do need any documentation on a green certification, we can provide that as well through DuctSox. So just reach out if you have any questions on what we can provide for any of those. Okay, and then wrapping up, just got 2 more slides here just to show you some examples, some fun little projects that DuctSox was involved in. As I mentioned, the Allegiant Stadium, where the Las Vegas Raiders play, where the Super Bowl was held last year, I believe. They used 2 72-inch diameter stacked on top of each other with that Skelecore full tension system, so that zero deflection system. It's all painted black like the rest of the stadium, and they're stacked on top of each other to make that oval look. They were able to save a very large amount of money to the project on this one. The cost for the product alone, obviously this is a very large product, but the product alone was a $1 million in savings versus metal. And then the labor cost was calculated out to be about a $2 million in savings. So almost a $3 million savings with this DuctSox systems if you factor in labor. So that labor cost, as I haven't really mentioned that during this presentation, the labor cost of this can really help out on projects. As I mentioned, it's a very lightweight product. You can see in this picture, they didn't need cranes. They didn't need to have these large cranes inside the stadium. They just had these brave individuals hanging by ropes. And they were actually able to pull and maneuver these sections into place just by 2 guys hanging by ropes. So a much quicker installation than metal would have been, and a much lighter solution, and ended up saving them quite a bit of money. So this runs throughout the inner section of the stadium. So it is painted black, so it might be tough to see, but you know, you might get lucky on TV or something to see it. Or if you ever go to the stadium, I'm sure you can look up and see these there. I also mentioned the Las Vegas Sphere. So in between those outer panels and the inner, if you've seen any videos of people inside, there's also screens all around inside. So there's 2 layers of screens for the outer screens and the inner screens. And to keep those cool, DuctSox has a 156-inch diameter sock going through it all internally to keep all those cool as well. So a couple of really cool products projects that they've worked on in the last couple of years to showcase their projects here. So, all right, with that said, that is all I have. It doesn't look like I have any questions, so that is okay. If you have any questions, please reach out to your Buckley representative, and they can help you out with anything. If you don't have a representative that you have been working with in the past, you can send it to sales@buckleyonline.com, and that can get somebody in touch with you to help you out. If you have any other questions, whether that be a part of this presentation, or if you have any jobs where you might want to look at duct socks or one of these destratification solutions, any of the products we talked about, please feel free to reach out. Again, I thank you all for joining today. I know it is your lunch hour, so we do appreciate you joining. And if you have any questions, please do not hesitate to reach out. Thank you again, and have a good rest of your weekend.